Welcome back from the previous episode where we spoke about the bytecode, the file structure. This time we are going to speak about Java architecture and the workflow. We will have overview of Java workflow, what's going on since the class loader started and what's runtime area, what is the interaction between all of these three components at the same time. So let's get into our animated presentation. We have a class loader. The class loader is getting your file and start loading it, but it doesn't do that on its own. It should do this with a cooperation with other components such as runtime data area, execution engine. So after the class loader finishing its work with the cooperation with the runtime data area, the execution engine will start initializing our application. Starting by class loader is going to receive your file and it will load it using the runtime data area. After that, the runtime area, it's already cooperated with the execution engine and Java native interface. Just in case if you have any native language used in your Java application, it will be stored in Java native interface, and the same as well with Java native method libraries if you are using it as well. The cooperation will be so simple. If you want something from there, you will call it, and if it is already, it will return back to you. Then going back again to the runtime data area where all the details and the instructions of the bytecode is stored. Then the class loader will load the file and continue its working. But how already the interaction with the runtime data area works, because what is the runtime data area stored already for us? From the previous episode when we spoke about the class structure, we had some class information stored somewhere in our Java runtime data area, such as the method area, and the method area is storing the class structures and the constant pool and the code for methods which use inside this class. After the method area, we have the heap. Heap is shared across multiple threads like objects or arrays storing in the heap. That to save more space in your application, so you can share some of the data structure or some of the objects between your applications. We have stacks. Stack, it means that each thread running in your application has its own local variable and a partial results coming from the cooperation between the heap as well, method invocations and return type. So stack is related to each single thread working. Heap is shared across multiple threads working. We have PC register, program counter register. For each thread has its own and address of Java virtual machine instruction in execution. So any class getting executed at this moment, the PC register will be following it and count it and put it into consideration as well. We have native method stacks. It's an instruction of native methods. Each thread has its own native method stack as well. You can even see from the name stack and another stack over here. That was overview of the workflow since the class loader starts to load your application and then initialize it. From the next episode, we will get into runtime data area to explain and describe each block independently to see what they have in common and what is the difference between them as well. So that's going to be the next time, class loader workflow. So thank you so much for listening. If you have any question in the comments, please leave it down below. See you next time.